Okay, so now let us to look at one series. 1 minus 1 over 4 plus 1 over 16 minus 1 over 64 plus 1 over 256. Apparently, this is an alternating series because the sign is keep changing. Okay. Not only that, we can actually write out the alternating series because for here you see this is 4. It's going to be 4 squared, 4 cubed, and then 4 to the power of 4s. Okay, so basically this is what we can write out. So we can write this as a n from 1 to infinity, negative 1 over 4 to the power n minus 1. Okay, so we can write into that way. Apparently, this is a geometric series with the common ratio is negative 1 over 4. And we know that for geometric series, if the absolute value of the common ratio is less than 1, then the geometric series converges. So we know that the absolute value is 1 over 4, so for sure it's less than 1. So we can get the conclusion, this series, if we view as a geometric series, it converges. Okay, it converges. Now, let's do something. If we change the sign, change the negative all into positive. So we're going to have 1 plus 4, 1 plus 1 over 4, plus 1 over 16 plus 1 over 64, etc. And as you can see that this is still a geometric series. Okay. And we can write it out as 1 over 4 to the power of n minus 1. And it turns out that the common ratio becomes 1 over 4. So it is satisfied to be a geometric series with the common ratio absolute value is less than 1. So we know that series also converges. Okay. But I would like to let you know to do a little bit comparison is from this one to here. What I did is I actually put an absolute value for my an. So this is the absolute value series for my first series here. Okay. So, and also you can see that absolute value, so it becomes into this. Not only that, we can also get as a conclusion that my original series is less or equal than the absolute value series, right? Because no matter this an part is positive or negative, this inequality holds all the time. Okay. And based on the direct comparison test, we know that if this larger series converges, then the small series also converges. Okay. So in this situation, we're going to introduce a concept is called the absolutely convergent. That means give you a series. If the absolute series converges, then we call that series is absolutely convergent. Meanwhile, if a series is absolutely convergent, then the series for sure itself is convergent because the absolute convergent is more, let's say, it's more strict than regular convergence. Okay, meaning if it's absolute converge, it definitely is converge. Okay, but if you change the pattern, if a series is converged, it may be absolute converge, it may not. Okay. So the concept is called the series an is absolutely convergent if the absolute series converges. That's what it just said. Okay, and also the absolute convergent theorem said that if a series is absolutely convergent, the series must converge. Okay, so from this short example, I introduced the concept of the absolute convergent. Okay, and hope you enjoy this video, and thank you for watching.